Alright, hello everyone. So in this video, we're going to talk about the visual representation of the R formula. Now, before we begin, let us just do a quick recap on trigonometry in 360 degrees, whereby we go back to the definition using the unit circle. So here we have this blue circle is a unit circle, radius 1. And here we have theta is 47 degrees. Now, how sine theta and cosine theta is defined is actually the angle that is created, and the sine and cosine theta is actually the coordinates, the x and y coordinates of this point A. So if I were to just switch on these two right now, we see that this coordinate A has the x coordinate of cosine theta and the y coordinate of sine theta. If I were to just right click, it shows here 0.68, which is the B cosine theta, and 0.73, which is sine theta. Okay, so just a very quick recap on how trigonometry is defined across 360 degrees. Okay, so let's just do a very quick animation here. We see that this is how we actually get all the values of sine theta and cosine theta. And with that, let's slowly dive into the R formula. So let me just set a few things first. So now let's say we have a radius of 4 for the blue circle. So which means I would have 4 sine theta. Okay, as of now, theta is 52 degrees. And then the y coordinate will be 3.15, which corresponds to basically the length of this arrow, A sine theta. Now let us overlay with another circle of radius 3. That will give us the B cosine theta. We'll see that A sine theta was 2.54, B cosine theta is 2.31. It adds up to 4.86. Now, however, we realize that, hey, I can't really see this 4.86 on this diagram right now. So what we can do is this. Here's a trick. My trick is this purple circle, we can actually rotate it and translate it. Okay, that's why you see the word translate and rotate here, right? And I'm going to shift the center of this purple circle to this point here so that I can actually add up the lengths of A sine theta and B cosine theta kind of stack on top of each other. So let us take a look how that looks like as I translate and rotate. With that, A sine theta plus B cosine theta now gives me the length 4.86, which corresponds. And so let us see what happens when I drag theta to another angle and see what actually happens. And we see that if I were to just drag to another angle, maybe like 66.5, then A sine theta will be 3.67, B cosine theta is 1.2, it gives me 4.86. And now we're just wondering this, what happens if I were to animate and trace B? And we actually see something really, really, very, very interesting. What we see right now is that the coordinate B is actually tracing out another circle. And that leaves us to wonder, wow, what is that? What's the radius of this circle right now? And so to show us this new circle and its radius, I'll switch this on right now. What does it give me? It actually gives me this new radius, which is actually the square root of a squared plus b squared, the use of Pythagoras theorem of the two radii of the blue and the violet circles, which then gives me this, all right? 4 squared plus 3 squared gives me 25. The root of 25 gives me 5, which gives me this new radius. What else do we have? If I were to just bring it back to 0 degrees, point B is sort of like the new starting point of the tracing, where theta is 0 degrees. What do we then have? We have the alpha, which corresponds to the R formula, right, where we have to find that new alpha bit there. So with this alpha, it shifts the point B ahead by 36.87 degrees. And how do we get this 36.87 degrees? It is basically the tangent inverse of B over A. And with that, when we animate it, it starts at the 36.87. It will go around, okay? And once theta reaches 360 degrees, it goes back to this point, okay, where my cursor is right now. Pretty cool, huh? Let it just go back. Okay, let's just enjoy this animation. Okay, I'm just going to put a stop to this first. Okay, so right now we're just wondering, if it was for A sine theta plus B cosine theta, how would it then look like for A sine theta minus B cosine theta? Let's just take a look. Now, for A sine theta minus B cosine theta, we will want to start off by subtracting B cosine theta. So we have A sine theta, we subtract B cosine theta. It's kind of going downwards from this point, and that gives us 1.56. And lo and behold, what do we then have? We animate and trace we once again have the same idea of the new circle and the radius, okay, and the accompanying angle that shifts that point B is once again alpha. Okay, we can't really run away from the whole idea of Pythagoras theorem and that bit of right angle trigonometry. Okay, and wait, let me just stop the animation here. And we go back to theta equals to 0. So where does it start? It starts with the point B shifting backwards by 36.87 degrees. Now that's the reason why a sine theta minus b cosine theta equals to r sine bracket theta minus alpha, because moving we're moving that amount of angle back to get to this point B. So that shows our a sine theta plus b cosine theta and the minus version. So how about the cosine version? So let me just bring everything back again, and let's just switch to a cosine theta plus b sine theta. Okay, so now if I just drag to another new angle, let's say a cosine theta is 2.93, okay? This time, this will be the x coordinate, and this is the y coordinate. So question is, how do we then translate and rotate such that we actually measure the addition of those two lengths? So here is how the translation looks like now. Okay, I shift and translate so that I am measuring the total x coordinate or the x length, okay, to give me this 4.97. And you realize, hey, isn't this a very similar animation for the sine theta? Yes, of course. And let's just take a look, okay, as we start to animate and trace. And once again, we have the same diagram, okay, a very similar diagram, maybe just except the plus and minuses and what we're actually measuring, okay. And what we're measuring is the total length, okay, of a cosine theta plus b sine theta. And let's just stop the animation, bring it back to 0. So we know that a cosine theta plus b sine theta is r cosine theta minus alpha. So where did this minus alpha come from? Let us show this new circle and radius. And maybe I just shift out a bit. Maybe let's remove this. A cosine theta plus b sine theta. In order to add it this way, we notice that, hey, this point B has to be shifted in this manner. And then we realize, with the new circle, it is actually shifting the point B backwards by, there you had it, alpha, which is 36.87 degrees. How do we get this? Once again, tangent inverse B over A. Okay, so last one, which is a cosine theta minus b sine theta. How do you think it's going to look like? Well, I think you probably have guessed it. It will be kind of like rotated the other way around. And let's just take a look with this. So this is a cosine theta minus b sine theta. A cosine theta is we're shifting ahead by 3.37, but b sine theta is 1.61. We're minusing it away, so it shifts back. And that gives us 1.76. To have this effect, we need to translate the violet circle, okay, in the anti-clockwise manner, which gives us this diagram. And then when we were to animate, okay, we realize that the point B, with respect to the new circle, okay, is shifted forward by 36.87 degrees, which is alpha. And that is the visual proof for our formula, with the idea of using circles in trigonometry to prove to us why the R formula actually works, not just for acute angles, which I think there are a lot of proofs out there that actually makes use of the right angle triangle, but it doesn't really cover the whole 360 degrees. So I hope with this animation here, it helps you visualize a lot better why the R formula actually works across 360 degrees. Okay, right, that's all.